Hello everyone, welcome to my channel Imbibe. Today in this video we'll discuss on the topic Law of Conservation of Mass. You might have heard about John Dalton. John Dalton postulated his famous atomic theory, which you might have heard, and later on he proposed in his theory of the atom that atoms can neither be created or destroyed, but change from one form to another. That means the atoms could neither be created nor destroyed, but they could be changed from one form to another. Hence, matter too, which is made up of atoms, can neither be created or destroyed. Later on, Lavoisier in 1789, he formulated the law on the basis of experimental evidences. He heated tin with air in a closed vessel and found that the mass of tin and the air before the chemical change. It remained unaltered even after the chemical change, producing SnO2 or tin oxide, provided the temperature remained constant. Hence, before and after the experiment, the mass remained unchanged. Or it remains same. Now, the next thing what we are going to do is we'll state the law of conservation of mass. So by now, what you can assume or what you have learned is about law of conservation of mass, that in any chemical reaction, the total mass of the reacting substance or substances is equal to the total mass of the products of the reaction provided masses are measured under similar conditions. So, in any chemical reaction, the total mass of the reacting substances is equal to the total mass of the products of the reaction, provided the masses are measured under similar conditions. Okay, for example, if I explain the above statement, what I have to say is, if A and B, for example, if A and B react to form C and D, then according to law of conservation of mass of A plus mass of B is equal to mass of C plus mass of D. For example, I can also take the example of iron sulfide. For example, in the formation of iron 2 sulfide, sulfide. By heating iron and sulfur, 56 parts of iron, for example, mass of iron is 56. 56 parts of iron plus mass of sulfur, that is 32. 32 parts of sulfur chemically combine to form 88 parts of FeS, mass of iron. 2. Sulfide would be 88. That means adding the mass of iron and mass of sulfur, it would give 88 mass of iron 3 sulfide. Okay, so in the formation of iron 2 sulfide, by heating iron and sulfur, they will chemically combine to form 88 parts of iron sulfide. Even if we discuss more elaborately by studying an experimental study by Landolt. Landolt studied the law of conservation of mass in case of a double decomposition reaction. In case of a double decomposition reaction. In a special tube, two solutions of sodium chloride NaCl solution and AgNO3 or silver nitrate solution were taken in two limbs of a U-shaped tube and the limb sealed. The tube was then weighed and then tilted to mix the solutions. Sodium chloride reacts with silver nitrate and a precipitate of silver chloride is formed. Silver chloride is formed. The tube is then reweighed. The conclusion drawn from the above experiment is the weight before and after the experiment, it remains same. How it remains same? Let me show. Or if we calculate, we will find that NaCl plus AgNO3 gives AgCl, which is precipitated, plus NaNO3. If we weigh, sodium has atomic mass 23 plus chlorine 35.5. Ag108 plus nitrogen 14 plus oxygen 48. This will give a sum of 228.5. Now if we calculate on the product hand side, 108 plus 35.5, sodium 23 plus nitrogen 14 plus oxygen 48. This will also give a sum of 228.5. So the total mass of reactants and the total mass of products, these both are equal. Therefore, he proved that the way before and after the experiment, it remains unchanged or unaltered.